Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Izun Nafis Ibadik. Here I would like to present my research work with the title Frequency Domain Energy Detection for Multiband Spectrum Sensing in Cognitive Radio System. I also would like to thanks to the committee of the ICT that allowing me to present at this event. Okay, this is the outline of this presentation. There will be five parts. It started by introduction and closed by the conclusion. Okay, next is about the introduction. So this is the background of our research work. We know that the current wireless communication system relies on a static spectrum band allocation for transmitting the information. This mechanism leads to a spectrum scarcity. Ironically, some literature show that many allocated spectrum bands are underutilized. Of course, there are some spectrum band that is overused. Then we need to maximize the usage of the spectrum band that is underused or underutilized. One possible solution is the one that is called by the cognitive radio system. Cognitive radio system is a system that has a special feature to process information that is needed by dynamic spectrum schemes, which allow a spectrum band to be used by any user interchangeably. In the system, there are two groups of devices. The first one is called by a primary user that has a dedicated license to a particular spectrum band. The second one is a secondary user that is permitted to use a frequency band as long as the band is vacant. The scheme that is used by the user is called by the dynamic spectrum access. Here, what is secondary user need to do? The first, it need to sense frequency band that is used by several primary user, and it decides which band that is vacant. If in that band primary user is inactive, then the secondary user can use the band to transmit the information. However, if in some moment the primary user is active, the secondary user need to stop the transmission process and find the other frequency band to transmit its information. With this mechanism, spectrum sensing process play a key part as for the dynamic spectrum access schemes. Next, about the system model. First, consider the model of our system in this problem. Here, the transmitter system consists of several primary users that occupies different frequency band. It's denoted by xkn. The result of the transmitter system is xn, that is acquired by sum of the signal from each primary user. With this system, we model a wideband system for the spectrum sensing process. And during the transmission, the transmitted system xn will be disturbed by noises. Here we simplify the noise by using adaptive wide Gaussian noises. The power of the noise is regulated by a parameter that is called signal to noise or SNR parameter. Okay, the detection process can be formulated as a task to decide whether the received signal are belong to one of two hypotheses. Here we denote the H null as the condition where primary user is inactive, and H1 as a condition where a primary user is active. Then from the received signal, we can construct a test function that's called lambda y and compare it with the threshold to decide whether the received signal is belong to H0 or H1. After the decision, we can evaluate the performance of the detection by calculating the value of probability of detection and also the value of probability of false alarm. One of method to perform the detection process for the wideband signal model is by using the multiband spectrum sensing approach. With this approach, we need to split the received signal into some narrowband signal, which each of them only contains frequency component that is corresponding to one primary user. For this task, two approaches can be conducted. The first one is time domain approach, where we use a filter ping HK and perform convolution operation to split the signal. The second approach is conducted in frequency domain. Here we calculate the power spectral density estimation of the received signal. To analyze the presence of a single primary user, we need to analyze the PSD value in the frequency that is corresponding to the mentioned primary user. The next part is the method that is used in this work. But before that, in the previous research, there are some method that is implemented for spectrum sensing process. There are energy phase detection, covariance phase detection, and so on. Here we want to compare the result from the energy detection method and machine learning based method with our proposed method, especially in multi-band spectrum sensing scenario. Majority of current work propose the spectrum sensing method using narrowband assumption, including this energy detection method. Then, for the purpose of comparison, we modify the energy detection based method so it can be implemented for the multi-band spectrum sensing approach. First modification in this method is conducted in the test function. The energy detection method is analysis of signal that use the time domain signal representation. The test function is constructed by the sum of the signal that is squared. Because of the presence of the filter bank in multi-band spectrum sensing approach, we need to ignore some of the sample to ensure that the test function is computed based on the independent sample. So the formula becomes showed in the screen. So, the second modification is conducted in the threshold. Here we redefine the variance of the sample because of the presence of the filter bank that I mentioned before, and also modify the number of considered sample that's here denoted by G. After this modification, we can compare the test function and the threshold to decide the presence of the primary user signal. The next method that is used for comparison is the Cummins clustering based method. This method is already proposed by Kei Jun Lee in 2018. This method uses a frequency domain approach for the detection process. It calculates the power spectral estimation of the received signal and cluster the result of the estimation into two groups using Cummins clustering algorithm. And then the presence of the primary user is then decided based on the number of frequency points, where the PSD estimation belongs to a group that has a bigger average PSD estimation value. And this is our proposed method. This method is a frequency domain approach for the detection process, and there are two steps in the detection procedure. Same as the energy detection method, it is designed to give a specific probability of false alarm value as the detection performance result. Here, in the first step of the detection, the PSD estimation of the signal is compared with a threshold that we call eta 1. The PSD estimation is called by Wells method, and because of that, after some statistical analysis, we can obtain the threshold as the function of inverse complementary cumulative distribution function of the chi-square distribution, and also there is a contribution from the variance of the noise, also from signal element that is denoted by Z, and also number of sample that is denoted by L, and also the contribution from the modification window. The formula is shown in the screen. The detection process results into a binary value, which it will turn to be 1 if the PSD estimation is more than threshold, and turn to be 0 if the PSD estimation is less than the threshold. So after that, there is a second step. In this step, the test function is calculated by counting the sum of the result in the first detection process. because the probability of the result from the previous detection process turning to 1, it will have a probability using it can be measured as a binomial process. Then the result in the second detection process can be decided based on the calculation of inverse binomial distribution. Here we can set the probability of false alarm to a specific value and set the mu k as the number of the frequency point that belong to a primary user, and decide the value of threshold eta 2 by considering the binomial distribution. Okay, let's move to the result for this work. So this is the setup of the experiment. The experiment is conducted for the wideband spectrum sensing scenario. Here we use 5 primary users, and for each detection process we use 10,000 samples as input. And for the filtering process in filter bank, we use impulse response that have 200 samples. And also for the probability of existence for each PO is set to be 0.5. And also we use IEEE standard that the detection mask can perform detection where the performance is less than 0.1 for the probability of false alarm and more than 0.9 for the probability of the detection. So this is the first experiment. It's conducted to decide which method that can perform better in low S energy scenario. This is the result from the energy detection method, and in the right screen it's result from the Cummins clustering method. And this is the result for the proposed method. From the result, we know that the proposed method can give a better detection performance in lower energy scenario. The poor performance that is sought by energy detection method is caused by the reduction of the considered sample in the detection process. It leads to poor detection performance. In other part, for the Cummins clustering method, it also gives a poor detection performance because it doesn't use an optimal research decision that also lead to a poor detection performance. But however, the Cummins clustering method can perform better detection performance compared to the energy detection method. Okay, the next part is an experiment that is conducted to know which method that can give a consistent detection result if the number of sample is reduced. Reduced number of processed signal sample can offer some benefit. One of them is decreased sensing time. The result is the energy detection method can maintain the desirable detection result if the number of sample is more than 2,500 sample, whereas the Cummins clustering method is 6,000 samples. And this is the result of the proposed method, which can always give a consistent detection performance even if the number of sample is only 1,000 sample. Of course, in the energy detection, the reduced sample affect its performance. The energy detection method uses an analytical approach that considers the distribution of the test function. If the number of sample is reduced, then the distribution function of the test function in the H null condition is become closer with the distribution of the test function in H1 condition. Then it's become impossible to decide a threshold that can separate between the two distribution. For the Cummins clustering method, the lower number of samples also lead to poor detection performance. Since it's not use optimal research detection, the method has a tendency to detect received signal into H1. Then the lower process sample that is used, then PFR, the result of the PFR is also become lower, and it's also affect to the performance of the probability of detection. So this is the last scenario in this work that is conducted in this work. We want to know what is the result of the detection if the detector didn't perfectly know the noise power in the received signal. The result is only common clustering method that can achieve consistent performance in the unknown SNR condition. This become clear since the other method use the noise power knowledge as part for the threshold analysis. Okay, and this is for the conclusion for this presentation. From our work, we can conclude that the proposed method can outperform the existing method, especially in low SNR scenario and also in the small number of processed sample. However, the proposed method require a perfect knowledge of the noise power. If the system cannot provide it, the K-means clustering method can be used as an alternative method for the spectrum sensing system. Okay, I think that's all. Thank you very much for the attention. Wassalamualaikum warahmatullahi wabarakatuh.